Hey guys, in this video we're going to learn how to use a micrometer, how to read a micrometer. So we're going to be using analog micrometers, not digital micrometers. Digital micrometers are pretty easy to use. So if we want to focus on what we have here, I have a display. I have a variety of micrometers here in this case. I have a lot of different micrometers. They all come in different sizes. So you can see here, this micrometer here measures from 0 to 1 inch. And then if I get the next one size up, and it measures from 1 to 2 inch, and so on and so forth. So here's a 2 to 3 inch, and so on and so forth. So you have a lot of options here when choosing the right micrometer. Now, before we get started, before we start using micrometers, before we get into the technical, I always like to encourage students to look up the specifications. So we have a car here just behind us, and we're gonna look up the specifications. We're gonna be measuring the brake rotor on this car. We're gonna look up the specifications of the rotor, and you can see here the original thickness. If we scroll over to the side here, it says 1.03 inches, okay? And that's the original thickness, and minimum is just underneath it. If we zoom in, it's 0.98 inches. Now, what's that telling me is, I'm assuming that the rotor, I'm gonna start with the 1.3 inch. I'm gonna assume that the rotor is original thickness. I'm gonna assume it is in good shape. Now, the reason why this is important is because if we go back to the box with the micrometers, I now know, based on my specifications, I now know I have to get a micrometer that can measure 1.03 inches. So for example, I have to grab a micrometer that measures 1 to 2 inches. If I grab a smaller micrometer, like this one, it's a 0 to 1 inch, this micrometer cannot measure above an inch. It's not possible. And if I grab something a little bit larger, the next size up, then this is a 2 to 3 inch micrometer, and of course, it doesn't measure below 2 inches. So the ideal micrometer to measure 1.03 inches would be the 1 to 2 inch micrometer. Also, on the frame here, we notice that it's printed as to the level of accuracy that this micrometer measures, and it's to the 4th decimal place, so the 10,000ths of an inch. We're gonna learn how to read a micrometer today. We're gonna learn how to measure like that. Okay, so now now that we know what size micrometer we want to grab, I'm going to grab the 1 to 2 inch micrometer. Now, grabbing the 1 to 2 inch micrometer, before I get started, there's a couple things we have to know. We have to understand that these tools are precision measurement tools. They're not clamps. They're not designed to be aggressive. We have to be very gentle with these tools. So right now, I'm always going to be holding the tool from the frame. Some of the other components here, we have this lock, which I generally don't use. In the project we have the anvil here, and we have the spindle. This part moves. Then we have the numbers here, right? We're going to be discussing the numbers very detailed. Hopefully we can see that with the camera. And then we have the knurled section here on the thimble. And there's 2 knurled sections, and these are kind of important. We're going to be discussing this a lot. I'm going to emphasize this a lot. We want to make sure that the tool lasts a long time, so how we handle it is super important. Now, this knurled section, the larger knurled section on the sleeve, or on the thimble, is for loosening. The smaller one is for tightening. And when we go to use that on the brake rotor, I'm going to emphasize that a little bit further. Okay, so before we get started, I want to make sure that the micrometer is clean. So I want to make sure I clean the 2 surfaces, and I might use a rag, which I did already, a rag or some paper towel, or I use the corner of my shirt, and I make sure I wipe any sort of dust or dirt or grease from these 2 surfaces, because it can measure dirt and grease. That's how accurate these tools are. Now, how to determine if the micrometer is accurate is closing it down until it's closed to see if the zeros line up. Now, me closing this micrometer where the zeros line up here, on the main reading line, I still have a 1 inch gap. So I don't really know if that's exactly 1 inch because there's a big gap there. Now, zeroing a micrometer like this micrometer where it's a 1 to 2 inch is pretty simple. I can close it using the small ratcheting stop, like I said before, and I bring it all the way down. And I can see here on this one, when we zoom in, the 0 does not line up. It's almost line up. It's pretty close, but this is not accurate. To make this accurate, the tool kit comes with a little wrench here. It's a little called a spanner wrench. I'm going to pull this out. And the spanner wrench is used to adjust the tool. And how we do that is we can see here, if we can zoom in, we can see that the main reading line is above the 0 on the thimble. And what I need to do is I need to move that main reading line, that line on the left side. I have to move that and I have to bring it down. The spanner wrench locks into a hole on there and I can move the main reading line up or down. Now you would do this with your teacher. This wouldn't be something you would do, but you would do this with your teacher. Now, once you have the micrometer zeroed, once you've cleaned it, you got to show your teacher that. The objective is to show your teacher that the micrometer is accurate before we get started, okay? So on this micrometer here, this 1 to 2 inch micrometer, how I check to see if it's accurate is I use one of these spacers here. So I'm gonna grab this 1 inch spacer because this measures as low as 1 inch. So I'm gonna grab this 1 inch spacer and I'm going to close the micrometer on this 1 inch spacer. If I close the micrometer on this exactly 1 inch spacer, then these zeros should line up. And we can see here that it does. I don't know if we can pick that up on the camera, and we can, yeah. See, they line up perfectly, okay? All right. Okay, so now the objective of this project here is to measure a brake rotor. Now, we already removed the wheel. We looked up specifications. In this case, it was 1.03 as the original specifications. Now, here's my brake rotor. So here's my micrometer that I'm going to be using. It's a 1 to 2 inch micrometer because I'm measuring above an inch. So when I measure something, a lot of times they want you to measure it in multiple locations, 2, 3, or 4 locations to determine the level of accuracy that the brake rotor is. Maybe it's warped, maybe it's no longer round, it's oval, whatever the case may be if you want to measure crankshaft. So in this case here, I'm going to be measuring at the 12 o'clock position, at the 3 o'clock position, and at the 6 o'clock position. Now, unfortunately, this can be a little difficult because when I'm measuring this brake rotor, I have to keep the micrometer there. I can't slide it up once I got my measurement because a brake rotor, you can see here there's a little bit of rust on the lip. If I go, so this is smooth, rust-free, and I pull my tool above that, there's a little bit of a lip. Obviously you're not gonna be able to see that in the video, but I can feel that it's a little bit thicker on the tip. So if I close my micrometer there, so it's down, it's tight, and I try to pull it up, I'm stopping right there. I can force it, but again, like I said before, we have to be very gentle with these tools, okay? All right, so how to handle this. So here we are, I'm gonna be measuring this at 12 o'clock. So my micrometer's open, I slide it over, and I wanna be roughly in the middle, not at the top, not all the way to the bottom, somewhere in the middle there. And I don't wanna tighten it with the large portion of the micrometer on the thimble. I want to use the small ratcheting stop. And that's because that's gonna limit the amount of tension I apply on the tool. The tool has a set desired amount of tension and I don't want to force it. I'm not going to take this portion here and crank it down. This is not a C-clamp, this is a precision measurement tool. So I simply just tighten it down until the ratcheting starts. And that's, I know in the video we're not gonna be able to see all these numbers here in this angle. We're gonna be moving it. Anyways, so now I would read it right where it is. So I'd have to get into some sort of weird position to read the micrometer, or I can take a picture with my phone and then I can look at it with my phone in a different angle, okay? So I'm gonna be measuring it there. Then I'm gonna loosen it using the large portion of the knurled section. Then I'm gonna be doing the same thing over here. And I'm gonna tighten it with the ratcheting stop. And there you go, it doesn't want to move anymore. I might wiggle it around a little bit just to see if I get an extra little bit of tightness on there, but I'm always using the ratchet to tighten. I take my measurement, loosen it off with the large thimble, and then I come down to the 6 o'clock position, and same thing, I'm using the ratcheting stop, and I have to read it right there, okay? Okay, so now, I'm not measuring it on the car for this video because it's very difficult to read. So what I'm gonna do is, I'm just gonna put this in a random spot. I'm gonna spin it and get a random spot. So now I learn how to read the micrometer. So this here, this micrometer is a 1 to 2 inch micrometer. I'm gonna do a couple of examples with this micrometer, and I'll do a couple examples with a different micrometer, and then hopefully you'll understand how to read a micrometer. You can rewatch the video a few times if you like. Okay, so now, if I take a look at the micrometer, and I know my number is supposed to be, and here's my example, I know my number is supposed to be 1.03, but it's a 4 decimal micrometer, so I'm gonna have 2 more decimals there. This is the example of what it should be. These are my example numbers, okay? So that's more or less what I'm gonna be looking at. So now I can take my micrometer, okay? Let's get into that area there. Okay, here we are. Okay, so I just put it in a random spot. So let's take a look at this. What are we looking at? Number one is if I see this number here, I have how many digits? I have 1, 2, 3, 4, 5 different digits. So when I look at that, I think to myself, there's 5 different steps. So what I like to do is I like to write these letters down, and I only do the 4 and I add the 5th at the end. That makes it a lot easier. I used to ask students to do the 5 steps in a row like this, and then students always used to place the numbers in the wrong spot. Okay, so step 1, letter A, step 1 is to represent this digit here. Now, since we have a 1 to 2 inch micrometer, then my answer is going to be 1 point something, right? Okay, step 2 is this digit here. Now, what I do is I look on the thimble. And let me open this up so we can see it. And I look to see what the largest visible number is on my thimble. And it was a 0. Now you can see there's a lot of options. 1, 2, 3, 4, 5, 6, and it goes all the way to 9, right? So let me close that back down to where it was before. And the largest visible number on my thimble for this example was 0. You can see here, 0 is the largest number visible on my thimble here. Okay, so that is represented as a 0.0000. Next is how many lines after the 0 do I see? Let's see if we can zoom in here. And I think it's 2 lines in this example. So this is not exactly perfect compared to what's on the rotor. So I see 2 lines after, and each one line stands for 0.025. A second line would represent as 0.050, and if I see a third line, that's 0.075. And since I see 2 lines, therefore, it's a 0.050, and I'll write that down, 0.050, okay? Now, where am I in between the 0.050 and the 0.75? And that's when I look at the movable scale here. And you can see here on the side, I am in between 4 and 5. And when I'm in between 2 numbers, which most of the time I will be, I would always take the lower of the 2 numbers. So I'd represent that as 0.004. Okay? Now, I'm going to add this up. And I'm going to start on the right-hand column. So 4 and 0 plus 5 is 5. And that one 0, add 1. Now, where am I in between the 5 and the 4? And that's where the vernier scale comes in place. And if I rotate this, I have to see what numbers on the left-hand side there, not the movable scale, not this sleeve, or not this thimble. On the sleeve, there's some solid numbers there, and I got to see what's lined up. And it looks to me like a 4 is lined up. And I don't know if we can see that in the video. I think we can. And the 4 is lined up. And I just tack that 4 on the end, and that's my size, 1.0544 inches. Okay, so let's do another example. Here we go. So I'm just going to spin this, let it land wherever it may be. Okay, so again, I have my number here. I'm going to start with writing down my steps. So A, B, C, D, and I'm going to add that up. Step 1 is to determine my scale. And my scale is a 1 to 2 inch micrometer, so therefore, because I have a 1 to 2 inch micrometer, so therefore my answer for A is 1.000. B, again, is the largest visible number on the sleeve. Largest visible number on the sleeve, in this case, is 5. And that 5 represents half an inch. So how do I represent that? How do I write that down, express it? 0.500. Then I want to look after the 5 and see how many lines do I have after the 5. And I can see 1 line. So that's represented as, or expressed as 0.025. It's very important that we place the numbers in the correct columns. Now, where am I in between the 25 and the 50? And that's where the thimble comes in place, the part that's movable on the right-hand column. Now you can see here, I'm almost at 23. I'm in between 22 and 23. I always take the lowest number. And you can see here how close I am to the 23. Some people might want to round up. There is no rounding when it comes to micrometers. These are precision measurement tools, no rounding. So you always take the lower of the 2 numbers. In this case, it's 22, and that is represented like this, 0.022. Now I add everything up. So 0 plus 0 plus 5 plus 2 is 7. 0 plus 0 plus 2 plus 2 is 4. 0 plus 5 plus 0 plus 0 is 5 decimal 1. Now, where am I in between the 22 and the 23? I'm very close to 23. So how I determine that is the vernier scale, and I'm going to rotate this. I'm imagining I'm going to be an 8 or a 9, and I don't know if we can see that on the video here. Are we at a 9, I think? Looks like a 9 to me. And I just simply tack that 9 on at the end, and that's my size, 1.5479. Okay, now I'm going to do another example. I'm going to put this away in my little box here. Now, I don't close this with a lot of force. I leave it somewhat loose, not under tension. I don't want to put these precision tools under tension, put it away in the cabinet, and leave it under tension. So I put that away loose. Now I'm going to grab the 0 to 1 inch micrometer. Again, I'm going to check to see if it's zeroed. I'm going to clean it first. So I'm going to use the corner of my shirt. Okay. Grab a corner of my shirt here and just give it a little wipe down just to clean the anvil and the spindle. Then I'm going to grab the ratcheting stop and I'm going to bring it down to a 0 to see if it lines up with the 0. And we can see here that it does line up. Okay, so I don't have to worry about anything. So now I'm just going to spin that, give it a whirl. Okay, let's use that. Now, this micrometer here is a 0 to 1 inch micrometer. So all my answers are going to be 0 point something. Okay, so again, 4 steps, and then we're going to add the 5th step on the end. So I'm just going to go ahead and take the time to write my 4 letters, A, B, C, and D, and I'm going to add it up. Step 1 represents my scale reading. In this case, this is a 0 to 1 inch micrometer, so I'm going to express it as 0.000. Step 2 would tell what is asking me for the largest visible number on the sleeve, and I think here we have 3. That's represented as 0.3, so 0.300. Then how many lines do I have after the 3? And I can see no lines, 0 lines. So I'm expressing that as 0.000. And where am I in between no line and the first line? So between 0 and 0.025. That's where I go to the thimble on the side. And you can see here, I'm in between 16 and 17. I'm approaching 17. Do I round it up? No, I don't round it up. There's no rounding. So I'm at 17. Actually, I think I do see one line there. Do I see one line? No, there's no line. So, and I express that I'm at in between 16 and 17, and I express that as 0.016. Now I add everything up. I got 6, 1, 3, decimal, 0. And now where am I between the 16 and the 17? And that's where the vernier scale comes in place. Now, if we take a look, we're really close to the 17, so it's going to be a high number, like 7, 8, or 9. And I'm going to take a look, and you can see number 8 lines up. Okay, so then I'm just going to tack a number 8 on the end of my answer. And don't forget my inch marks, 0.3168. Now, let's do that one more time. This will be my last time I do this. I'm just going to give it a spin, give it a whirl. Let's get a bigger number there. Okay, all right. So, again, I'm using a 0 to 1 inch micrometer. So I have to keep in mind that all my answers are 0 point something. There's still 4 steps or 5 steps to acquire the right answer. I'm going to start with just the 4, and I'm going to tack the 5th step on the end. Makes it a lot easier. So what I start doing is write my letters down, A, B, C, and D. Since it's a 0 to 1 inch micrometer, my answer is going to start with a 0.000. B, I'm going to look at the largest visible number on the sleeve, and it's a 6. And that's represented as 0.600. And I'm going to look to see how many lines do I see after the 6. And I can see 1 line after the 6. So that's represented as 0.025. Now, where am I in between the 25 and the 50? And that's where the thimble comes in place. And you can see here, we're almost at 10. We're at 9. So that's represented as, remember, we always take the lower of the 2 numbers where we're in between. And that's represented as 0.009. Now I add everything up. 5 plus 9, this is a good one because a lot of students tend to forget this very, very simple math. And I'm glad that I landed on this. So 5 plus 9 is 14. So a lot of students, believe it or not, this is kind of funny. I know this is you might laugh. A lot of students forget how to do simple math. They pull out their calculator, they pull out their cell phone to help them with this math. It's really simple. What you're going to do is 5 plus 9 equals 14. I don't write 14. I don't write both digits down here. I only write one digit. What digit from 14 do I write? The 4. So I write the 4 down, and then I carry the 1. You guys remember doing this back in elementary school? I carry the 1 to the top, so now it's 1 plus 0 plus 0 plus 2 plus 0. So 1 plus 2 is 3. And 6 is the only one in that other column. Decimal, 0. Now, where am I in between the 14 and the 15? Well, that's where I have to, or between the 9 and 10, sorry, where am I in between the 9 and 10? That's where the vernier scale comes in place. And again, we're pretty high up there, so it's probably going to be a 7, 8, or 9. And you can see there in the video, or in the camera there, in the picture, that 9 lines up. So I'm just going to tack a 9 on the end. And that's it. That's my answer. 0.6349 inches. Okay, so now I'm done, and I'm going to be putting my tools away. All right, so what I'm going to be doing, you see this big gap here? I don't want to leave this big gap here because if I leave it like that, I can't even close the package. It doesn't close. Okay, I can't close the box. So I have to close it a little bit. Now, I'm going to take the thimble and I'm going to close it, but I'm not going to close it all the way. I'm going to leave a little bit of space so that my tool is not under tension. And I'm going to make sure that I'm not locked. My locking mechanism is to the right. I'm going to put it back in the box. I can clearly see that I have space to close my box. I can lock it. I'm going to hold this with 2 hands. Don't grab it from the handle here, guys. Treat it with care. And I'm going to grab it like this, like a dinner plate, and bring it back and put it away in the cabinet or the tool room, wherever you're supposed to put it. Okay, guys, thanks for watching. Hopefully that helps.